Hello and welcome to the IPSec lecture. In this lecture, we'll talk about IPSec. We'll see what are the IPSec components and the protocols. We'll see the difference between the main mode, aggressive mode. We will see IK version 1 messages and IPSec messages. Also IK version 2 messages. We'll see the difference between the tunnel mode and transport mode. We'll see how an IPSec connection is established. We'll check the NAT transversal, and I will show you some sample config from IPSec. So what is IPSec? As you know, the IPSec is used to establish a secure connection or encrypt communication between two devices over internet. You can use IPSec either for remote access or for site-to-site applications. Basically, site-to-site applications are used if a company have some HQ and some branch offices. You can use IPSec to establish a communication between the HQ and the branch offices, and all your traffic will be encrypted, and a potential hacker or attacker will not be able to decrypt this traffic. At least he will not be able to do this easily. Okay, so IPSec will create a tunnel, and all the data which is passing this tunnel will be encrypted. Also, you can use different levels of encryptions. You can use stronger encryption, you can use weaker encryption. It depends on what device you have and what encryption standards it will support. I would like to start to tell you about the IPSec components and the IPSec protocols before we dive deeper into the IPSec operation. So some important IPSec protocols are, or let's say components, are security association, which is also called SA. And this is a logical connection between two hosts that is describing the security parameter. When I say the security parameter, I mean the hash algorithm, the encryption algorithm, the authentication method, and so on. These security associations are stored in a security association database, and individual entries are called SPIs. Also, we have the security policy database or SPD, and basically it's a table or a database which contains rules which will determine if an IP packet should receive IPsec treatment or not. In other words, this database is deciding if a packet should go over the IPsec tunnel or if it should be sent as using normal routing. We have a suite of IPsec protocols. IPsec basically is not a single protocol, but it is a suite of protocols. And IPsec will use authentication header, which is adding a header to each IPsec packet, which is containing a hash value and a secret key, and they are used at the destination to check the packet integrity, and it will check if the packet wasn't modified along the way. So in simple terms, it will add authentication and integrity to the packet. Also, we have the ESP, or the encapsulating security payload. It is a protocol which is similar with authentication header, and it is provided authentication and integrity to the packet. And it also allows data encryption using an encryption algorithm. Also, we have iKey, or Internet Key Exchange. You have iKey version 1, or we can have iKey version 2. iKey version 1 is the first iKey version. It is limited in functionality, and iKey version 2 is the newer version. which have a lot more feature than IKv1. We'll talk about this later. So basically, IK is a protocol which is establishing a security association between two hosts, and it will negotiate and check configured authentication algorithm, encryption algorithm, and integrity algorithm along with security keys. It is also important to know if we have configured two set of parameters on each device. If those parameters will not match, IK will not be able to set up an security association. Also worth mentioning that IK is much faster and reliable and secure than IKv1. Also, we have ISA KMP, which is Internet Security Association and Key Management Protocol. And ISA and KMP is basically a component of IK, which is handling negotiation, establishment, and deletion of security association and related parameters. We have the Diffie-Hellman group, which is also a part of IK. And Diffie-Hellman is a secure way to exchange cryptographic keys over insecure environment. Internet is one example of those insecure environments. And we have perfect forwarding secrecy. Basically, it is the same like Diffie-Hellman group, but it will use Diffie-Hellman ephemeral keys to encrypt data transmission. And if you are using the PFS, then PFS will renegotiate a Diffie-Hellman key, which can be generated on a timely basis, like 1 hour every 30 minutes and so on. You can specify this time in the configuration. So as I said, IKv1 is the older protocol, and IKv1 can have two operational modes. It has the main mode and the aggressive mode. The main mode is the most secured mode for IPSec using IK version 1, and it is intended for the devices which have the fixed location, meaning the devices in the data center which are having the same IP every time. In IK main mode, the negotiation messages are encrypted. You will have to have an initiator and a responder. The initiator will be the one that will initiate the IPsec connection, and the responder will be the one that will respond to the initiator's request. IK version 1 in main mode is using 6 messages during the negotiation. Also, it is worth mentioning that when you set up an IPsec tunnel, you basically have two steps: the IK negotiation and the IPsec negotiation. So in IK version 1, running in main mode, you will have a total of 6 messages during this negotiation. The first message would be that the initiator will propose encryption and authentication algorithms. The second message will be sent by the responder, which will send its own set of proposals like encryption and authentication algorithms and the Diffie-Hellman group. The message 3, the initiator will send its public key to the responder using Diffie-Hellman key exchange. And in the fourth message, the responder will send its public key to the initiator using Diffie-Hellman key exchange. We'll talk about how this whole process works in more detail in the next slides. Message 5 and 6 are all encrypted, and then the fifth message, the initiator will send the authentication data to the responder, and in the sixth message, the responder will send its authentication data to the initiator. And at this point, the phase 1 of the IPsec is up. But we also have the second phase, which is called the IPSec negotiation. And IPSec negotiations are happening in quick mode, which means that only 3 messages will be transmitted. And those 3 messages contain encryption algorithm, authentication algorithm, encapsulation algorithm, security association lifetime, and IPSec mode, tunnel or transport, which we'll also talk in the later slides. And after the quick mode negotiation or IPSec negotiation is done, the IPSec phase 2 is up. We can check the messages in my lab simulation right here. I have configured it using the IK version 1. And let me start the packet capture here. And let me initiate the IPSec tunnel. You can see it is established, and this is what I was talking about. You have 6 messages used for the phase 1 setup, and you have the quick mode messages using for the phase 2 setup or for the IPSec setup. For example, if I go on this Linux machine here, and if I ping this Linux machine here, if we'll check the trace, we'll see that the packets are sent using the ESP protocol. And as you can see, the ESP protocol doesn't have a port number, but we'll talk about this in the later slides. Also, it is worth mentioning that these packets are carrying the actual data. In this case, they are carrying the ping messages. Also, we can have the IKv1 operate in the aggressive mode. Basically, phase 1 will be much shorter. We'll have only 3 messages. And phase 2 or IPSec quick mode will be basically the same. Aggressive mode is used for the devices which are which don't have a fixed location. For example, the remote access VPN. You have your firewall, which is accepting the remote access connections, and you have your laptop, and on your laptop you have a FortiClient application, Pulse Secure, or Cisco AnyConnect, and you are using that application to connect to the firewall, and that way you have the remote access VPN. Aggressive mode is not as secure as the main mode because the negotiation messages are sent in the clear text. We have 3 messages instead of 6. We also will need a initiator and a responder, and also aggressive mode is used in IK version 1. Basically, the devices will exchange the same information, but more data will be concentrated in the first and the second message. For example, the first message initiator will send the proposal, which are the authentication, encryption, and algorithms, and they will exchange also the Diffie-Hellman key, and initiator will also send the authentication data. When I say authentication data, I mean the pre-shared key, or maybe the security certificate, or any authentication means. In the second message, the responder will accept the proposal sent by initiator, and it will send the authentication data to the initiator. If the authentication will be succeeded, in third message, the initiator will inform the responder that the authentication has been completed. And the IPSec phase of the negotiations, or phase 2, is basically the same as for the main mode. As I said, the IQv1 is the first iteration, and IQv2 is the new kid on the block. IQ version 2 have the most features. I mean, it has a lot more features than the IQ version 1. It is in general faster, and it is more secure. It is supporting automatically NAT traversal, and it has also a keep alive mechanism. The IQ version 2 will need just to send 4 messages to complete the phase 1 and the phase 2 negotiations. And we also will need to have an initiator and a responder. So the 4 messages are the IKEY SA init. Basically, it's the same message which is sent by initiator and responder, and they will contain the encryption, integrity, algorithm, DH group, SA proposal, and that's it. And message 3 and 4 is called IKEY authentication, and those messages are encrypted, and when transmitting these messages, the initiator and the responder will authenticate each other. Let's see them how they look in a real life scenario. I will go to IPSec, and I will choose IKv2. I'm using here pfSense appliance because it is very easy to change the IPSec configuration from here. Let me disconnect the old tunnel with IQ version 1, and let us connect using IQ version 2. So it is connected, and as you can see, this is the first message, IKEY SA init. In these messages, as I said, they are sending the parameters, and on the message 3 and 4, they will authenticate each other. And the rest of the messages are just used for the keep alive process. Also, you can observe that the source and destination port are 500. And for the main mode, the source and destination port is also 500. And if we go ahead and if we will ping the same host, looks like that I have to open another Wireshark. The actual data is also sent using the ESP protocol. Okay, so at this point we'll talk how the IPsec connection is happening. So it is worth mentioning that there are 2 types of IPsec VPN. We have the policy-based VPN and the route-based VPN. In the route-based VPN, basically the type of IPsec, either route-based VPN or policy-based VPN, is describing how the traffic is selected to be sent over the IPsec tunnel. So in the route-based VPN, if you have this packet, for example, entering the firewall, you will have the SPD database, and for route-based VPN, will have only to examine the destination IP address of the packet. And for the policy-based VPN, the firewall will inspect the source and destination IP address of the packet. Because if you have a route-based VPN, basically you have a static route which is telling the firewall which traffic should go over IPsec tunnel. And if you have a policy-based VPN, basically you have a set of policies which are describing which are describing that the packet with the source IP of, for example, 10.10.10.1 and destination IP address of 192.168.0.1 should get the IPsec treatment and should go over the IPsec tunnel. If there is no entry in the SPD, I mean if there is no entry in SPD that matches with the incoming packet, the packet will be forwarded using the normal routing. Why I am explaining this? Because in order to initiate the IPsec connection, a device needs a trigger. And in this case, which I am describing here, the trigger is the traffic that should go over the IPsec tunnel. So this packet will arrive at the firewall, and it will be selected as interesting traffic, or the traffic that should be sent over the IPsec tunnel. The IPsec tunnel will be down, so it will have to negotiate the parameters. So first, the IPsec will negotiate the phase 1 or the I key negotiation. So the initiator will send its proposals containing the authentication and encryption algorithms along with the lifetime of the security association. You can see the authentication. In this case, the authentication algorithm is SHA-1. Encryption algorithm is AES-128. The lifetime is 28800, and the Diffie-Hellman group is group 14. When this timer will expire, the IPsec will have to renegotiate the parameters. So the initiator will send its own set of parameters, and the responder will also send its own set of parameters. We have DH group configured, which is a mandatory parameter, and DH group is used to create the public keys. Basically, it will create public keys and derive private keys. The private keys will remain in the firewall database, and the public keys will be sent from initiator to responder and from responder to initiator. Since they have used the same set of parameters, basically the public key which the responder have generated will work with the private key which the initiator have generated, and vice versa. So they will exchange those public keys, and each side will take the received public key and the local private key to generate the same Diffie-Hellman key. At this point, the phase 1 of the tunnel is established, but after the phase 1 is completed, we cannot actually send the IPsec traffic because the data is being sent using the phase 2 of the IPsec. Basically, the phase 2 of the IPsec is doing the same thing, but it is doing the same thing over an encrypted tunnel. So you can call phase 2 as a tunnel inside the phase 1 tunnel. So based on the phase 1 setup, the initiator and responder will send a new set of parameters. You see in this case, this is SHA-256 and the encryption AES-256. And as an optional parameter, we can use the Diffie-Hellman group. We can have this configured. It is called actually the perfect forwarding secrecy, and you can either configure it or you cannot configure it. It's up to you, or better to say it's up to your organization security needs. The pfS will consume more resources than a regular IPsec. So based on the phase 1 setup, a new set of parameters will be exchanged, and this time, as I said, they will be exchange security. And after exchanging these parameters, a new IPsec key will be generated, which will basically encrypt and decrypt the traffic, which the actual data which will be sent. Also, at this phase, the gateways or the firewalls, initiator and responder, are deciding if the tunnel mode or transport node is being used. If we have the pfS enabled, as I said, a new key will be generated every hour, in that case 3600 seconds, and the key will be exchanged using the Diffie-Hellman process. It is what I have explained here. So, for example, if a malicious person will somehow magically gain access to our IPsec key, it most probably will not work, because a new key will be generated with each flow, or at every 3600 seconds, or depending on the lifetime configured here. We can have the IPsec in the tunnel mode, and we can have IPsec in the transport mode also. This is something you can choose from the configuration. And the difference between the two modes is that the tunnel mode will encrypt the whole packet. It will encrypt the payload, the data, and the header of the IP packet, where the transport mode will only encrypt the data, and the IP headers will remain the same. The tunnel mode is generally more secure, because the whole packet is encrypted, and it is used between two networks over the internet. And the transport mode is not as secure, and it is used between the two hosts. You can use it over the internet, but you will give up your source and destination IPs. Also, as you saw in the Wireshark traces, that IPsec is working on port 500 when the negotiations are done, and ESP doesn't have any port, and connection will be just portless, as ISP is a portless protocol. Because of this, because of the ESP that is a portless protocol, we have a problem. And the problem arises when one of the firewall is hidden under a NAT device. Because IPsec is performing the packet integrity, and when a packet will go over a NAT device, I mean the negotiation packets in this case, it will see that it will not have the same hash value as how it was sent from the firewall, from the initiator, for example, and it will drop the packet, and it will not allow the IPsec tunnel to be formed. Also, even if that would work, the second problem is that the ESP is a portless protocol, and when the packet will be arrived at a NAT device, it will not have a port to NAT to. So the solution in this case is to use the NAT traversal. Also keep in mind that IQ version 1 is not supporting NAT traversal. NAT traversal is only supported by IQ version 2. And during the IPSec negotiation using NAT traversal, the initiator will send the first packet, will send in port 500. The packet will arrive at the NAT device and it will generate a new packet with a random port. Since the NAT traversal is enabled also on the responder, it will know that the packet was traveling via a NAT device, and it will inform the initiator. So in that case, the initiator will send the packets using port 4500. Also, the negotiations will be done using port 4500. The port 4500 is the NAT traversal port, and the actual data, the ESP protocol, will be encapsulated in a UDP protocol, and in this way the ESP will have the source port and destination port of 4500. As you see here, I wrote random port and the destination port of 4500. This is because, as I said, this NAT device will change the source port into a random port, but when the packet will arrive back at the initiator, it will arrive with the correct source and destination port. Let's go ahead and check an example of the IPsec connection using the NAT traversal. Just let's wait a little bit for the devices to boot up. I will start a capture here and a capture here. Basically, in this topology, this device is an IPsec gateway, this device is an IPsec gateway, and these devices are doing that, and you can imagine that here is the internet. You can put this cloud right here, and this is the internet. Okay, so since the devices are booted, let's initiate the HTTP on those hosts. And let me ping this IP address here. So the IPsec is now up. And if we find our packet here, it would be great. And this is the right firewall, this is the left firewall, this is the right firewall. So the first packet will be sent using port 500, and on the receiver side you'll see that it will have a random port and the destination port 500. The second packet, which will be sent by the responder or from the device from the right, will have source port 500, destination port 500. And if you check the rest of the packets, the authentication, for example, they are done using the port 4500. And if I check the ESP in this case, as you can see, the ESP is encapsulated in UDP, and it has the source port of 4500 and destination port of 4500. And basically this is how NAT traversal works. It's a clever trick. And last but not least, this is if you are a network engineer and you will have to configure a IPsec tunnel. basically you will get this table here. This table is describing all the parameters and that should be configured. You should have your endpoints, the side 1 and side 2. You should have the IQ version. In this case, I used IQ version 2. You should have the encryption protocol, the authentication or the hash algorithm, the Diffie-Hellman group, the lifetime, and if this is an IK version 1, you should also have the negotiation mode. On IK version 2, you don't have this. And for the phase 2, you should have the protocol. It can be either ESP or HA. You should have the encryption algorithm. You should have the authentication method, the security association lifetime. You should specify if you want the perfect forwarding secrecy, and if yes, you should specify the Diffie-Hellman group for that. I hope that you understood why both parameters have to match on both sides, because if one of the parameters will not match, then the key generation process will not be successful, and the IPSec connection will just not go up. So it's very important that both sides have the same parameters. Thank you for attending this lecture. I hope it was interesting for you. And in the next lectures, I will show you our topology and what we'll do next. So basically, this was the theory part of the lecture. And the next parts will be the practice parts. Thank you, and see you in the next one.